So this is a quick screencast, and what we're going to introduce here is utilizing SPARQL, linked open data environments, and service resource endpoints, along with the data graphs that we're experimenting with at dataoceandrilling.org. We're going to see how we can glue those together using tools like Google Refine. So let's go ahead and jump right into this. We're going to go ahead and be dealing with an actual raw SPARQL call across these particular graphs, these three particular graphs. In a production type environment, we might use something like the recently open source SPARQL to assist people to build these SPARQL calls, or we might use something like a faceted interface like the RPI S2S package to drill down to a collection of URIs in either case that are actually of interest to us and that we want to perform further operations on inside this workflow. For this example, though, we'll just deal with raw SPARQL. And in particular, we're going to be cutting across three particular graphs: the dbSEABED graph, which is lithology data, the expedition information graph, and the age model graph, the Chronos.org age model graph. The age models, of course, just give us age depth pairs so that we can associate an age with a particular depth at a site. We're going to be looking at Expedition 117, Site 731, particularly in this, and of course, programmatically, a person could look across multiple sites or multiple expeditions or as much data as a person wished to inside the graph, but we'll focus just on one for speed and brevity. Go ahead and start this query running. What we're going to be looking for in this query are a few parameters about the lithology: mud, gravel, sand, grain size, color, elements like this, as well as the depth that's associated with that. We're then going to go and ask inside the age model graph to see if there's an actual age model associated with this particular location, with the particular site. So you see the results back here. We get a URI for the lithology information and a URI for the age model, and then a set of parameters, values back in terms of observed top, observed bottom, the mud, gravel, sand, all these kind of components. Now, what we want to do then is load this into a package, and the package that I've selected is Google Refine. There are other tools that could do similar types of operations. The R statistical package would be able to do this, as should Microsoft Excel. In this case, I'm using Google Refine. It has some particularly unique features that I like in this. Now I'm going to load up a previously downloaded CSV version of the exact same query that we just did, and you'll see it loads in here into Google Refine and gives us our tables and elements like this. So we'll go ahead and create this project. Now, since we are dealing in a linked data environment, all these resource URIs should resolve, and in fact they do. We actually click on them and try and edit them. So you can see here, for example, this is the URL associated with this particular resource URI for lithology. And we see other associated information that we can glean from this. Of course, this is additional information associated with that particular entry. We can also go, if we want to, and pull up the core images that we have associated with this. So you can actually go and see the scans that were made on the cores. And of course, there would be multiple scans for these sections as we go down through that particular site. Additionally, both the lithology data and the age model data that we're using here are all represented using the RDF data cube vocabulary. So this working draft. So all that information, all those triples are put into this format. And the reason for that is that this information is sample-based. And because it's sample-based, we have thousands, millions of these sample records. And what we want to be able to do is create logical slices through them in ways, virtual collections of data that we want to look at. And so the RDF Data Cube does a wonderful job at that, and it's, I highly recommend it for people who are putting sample-based data into RDF triples. Of course, not only can we look at that resource, but we can also look at this one and see the actual age model that's associated with it from Chronos.org. So let's go ahead and get on with this. What we want to do is exploit a very unique capability, or I shouldn't say unique, but a nice capability inside Google Refine, which is to construct a REST call from that. Now, I've done this several times, so we can just pull into the history. But what we've done here is we've actually created out a REST call using values from the columns that we retrieve from our SPARQL query. So you can see we're taking the observed top here, and we're taking the value here, which is because we're creating a new column based on this column age model. We'll call it age call. You can throttle the delay here if you want. This is primarily if you were trying to hit endpoints that might monitor or limit the number of queries that you can make or number of queries that you can make per second or within a time frame. Since this is a service that we host on our own sites, we know for sure that we don't do anything like that. So we'll just put in a token 50 millisecond delay to get the results back from this environment. So we'll go ahead and say OK. And now what it's doing is actually constructing that URL and then making the request call on the net and retrieving back the results, and they'll put it into a new column here as soon as we're done. Okay, so we're done making our calls, and you'll see that we have the actual JSON call placed into this column now for all these REST calls that were made. This isn't probably what we want, right? So we can actually go through and transform these cells. Again, we can pull up into the history and utilize a Google Refine expression language call to actually parse JSON and get the actual age element of it. So we'll go ahead and do that, and we'll see we parse out all the ages. One nice thing we can do just to do some nice checking on the information that we have is we'll go ahead and attempt to convert all these to numbers, and then we can go ahead and take a look at facets, and since we're now numbers, we can do a numeric facet. And you'll see a range then now here of all the ages that we have associated with this. So you can see we have a kind of an interesting distribution of ages here that we've calculated. The other thing you'll notice though is that some of our ages are blank, and so we may be kind of curious as to why that's the case. And so what we can do then is we can actually look at those blank entries, and we can actually start to try to investigate why this is the case. And we see the ages, or excuse me, the depths that we're requesting here. And if we actually pull back up our age model, the red line is our age model. Now we actually had points that might have let us extend this age model on further, but we didn't. And in fact, we see that the age depth line of correlation ends just above 300 meters below seafloor. And so what we have a situation here is the lithology information going deeper than our age model. And so we don't have that, that information to present here. So this is just a situation where we could say we either just want the numeric results back, or if we wanted everything, we could go ahead and include our blank items, but we might have to extend the age model ourselves or get that information in some other way. So this is just a very quick screencast showing SPARQL calls across multiple RDF graphs, so we can do joins across those graphs and bring in more information into this graph, so that now we can convert depths to ages in that case, and we're cutting across expedition information in order to link those age models in. We see the advantage of using a linked open data type environment, because now we can actually go and investigate and peruse the information, be it the lithology or the age models, and discover core images that are associated with the lithologies and elements like that. All this tied together in a tool like Google Refine, or potentially something like R or Microsoft Excel. So hope you enjoyed the screencast. Take care.